Okay, so we're looking at identities now. We're doing this through the view of logarithms and trig, but we'll start off with example number 1 here, a very simple identity. Identities are just statements, mathematical equations that are already true, and we're just proving, we're kind of verifying that, that they are correct. We're going to use lots of tricks. We're going to have some algebra tricks, but we're also going to have specific tricks that are logs or trig that will come in handy. So how to do this? What we need to do is split up the statement to a left side and a right side of the equal sign, and we're going to pick a side, and it's not always clear as to which side we're going to pick. Most of the time there is an easier side, but it's really just doing 10, 15, 20 questions before you can really understand, well, which side should we choose. So I'm actually going to pick the left side on this one. So I need to prove that this left side turns into the right side. So now that I've chosen the left, I can only work with the left. So I'm going to go, squared means times itself. So I'm going to write x plus y, and I'm going to write it twice, timesing itself. And then I'm going to multiply it in. So x times x is x squared. And then x times y is an xy. And then y times x is another xy. And y times y is y squared. And then we've got some like terms. These ones are alike. There's an xy and another xy. So I can add them and I can get, well, there's two xy's. Now when I look, my left side matches my right side. So I can say, okay, my left side is my right side. That is it. I am done. I have verified this identity. I've proved that for any x or any y, this statement is true. Now that was a very simple one, but we do have ones that are going to require some logs, some rules about logs, some fractions, and what to do there. So as we go through this, we're going to have to kind of recall what are some of the log things that we learned in the previous unit. So I don't know which side is more complicated here. I'm going to do the left side here with the fraction. And one of the things you know is that whenever there's just a number on the denominator, you can bring that, or a letter in this case, you can bring it to the top and you can change the exponent from a positive to a negative or from a negative to a positive. So what I'm going to do is I'm going to say, okay, I've got log base a. But I'm going to take this x and I'm going to bring it to the top and I'm going to change the exponent, but I don't see an exponent. Well, there is an exponent. It says x to the 1. So when I bring this thing up to the top, it's going to become, the exponent's going to change to a negative 1. Now, there is just a 1 on the bottom, but we don't need that. So we're just going to have x to the power of negative 1. That is a algebra trick. The log trick in this case is that whenever you have an exponent here, you can just bring it down and turn it to a multiply. So I'm going to leave the x, but the exponent I'm going to bring down and turn to a multiply. So I'm going to bring this negative 1 down here and turn it to a multiply. So negative 1, I don't need the 1 when I'm multiplying, I just need the negative. So I just have a negative log base a of x. So what have I done here? I brought my exponent up, x to the 1 brought up, so I brought the whole term here, the x to the 1 up, but I changed the exponent to a negative 1. And then I've got the log law that says if you have an exponent, you can bring it down front and turn it to a multiply. And I didn't need the 1. And now the left side and the right side are the same. Left side equals right side. Okay, let's try another one here. So I'm going to split this. I only can pick one side. I'm going to pick the one that's more complicated. We did have a log law that said if the bases are the same, which is true for us right here, that both base a, you can put these together. Adding means that if you keep if again the bases have to be the same, you can put them together, but they're going to turn to a multiply. So this is an x plus y times x minus y. So this being multiplied. And then I can take this and I can expand it or FOIL it. So I can go x times x, x times negative y, y times x, and y times negative y. So I'm going to have an x squared minus an xy plus an xy and minus a y squared. And these are the same, but one's positive, one's negative, so those can cancel out. So I have log base A of x squared minus y squared. Now I've been putting square brackets around it just because I used round here, so I put square even further out. But the brackets don't actually matter here. It looks to me like this is the same. The left side equals the right side. So we merged it, we merged the logs, we then expanded or FOILed them, canceled out the like terms, and then we had the right side. So that had some algebra tricks, but it also had the log trick. The log trick was that you could join the logs together. Here we've got another log trick, and it has to do with, I think the very first log law, but maybe it's the third one, I can't remember, with exponents. So the idea is, maybe I'll pick the right side. This one, it actually doesn't really matter. But whenever you have an exponent, you can bring it down and turn it to a multiply. But it already is here. So we can work backwards. We can say, well, there already is a multiply. We can bring it back up and turn it to an exponent. So that's what I'm going to do here. I'm going to have log base A of C. And this is going to come up and become the exponent. So the exponent is 1 over b. So I think that's called some power rule or something. I can't remember. And so now we have the idea of changing things from radical form to exponent form. So we do this a lot in math 10 and 11. Where we'll have something like 9 to the power of 2/3. And we could say, well, the 3, we'll have the 9. You could change it to radical form. The denominator goes inside the little valley here, and then this is just on the top, squared. You could also put it here. It doesn't actually matter. The important part, though, is that the denominator becomes the inside of the valley. So that's the same thing here. So we've got log base A of C inside this radical. And the B, the number there on the denominator, goes into the valley. And then the numerator, that's just the power of 1. So to the power of 1. The thing is, we don't need the power of 1, so it's just going to end up being the B. So that, I think that's actually it. Yeah. Log base A, the bth root of C. So the left side equals the right side. So what was the rule there? Well, there was this rule that said a number that's being multiplied can be brought up and can become the exponent. And then we can rewrite it into radical form. Let's take a look at the next one. This one, has a different log rule and a different, it seems like that most of these here have a log trick as well as some sort of algebra trick. Now, which side is more complicated? It looks to me like the right side, so I'm going to stick with that. I can't even draw a vertical line here. Okay, well, that's not very good, but we've got this, and you can see, oh, they're the same, but they've been kind of flipped. Well, one of the things we can do is a log trick, which is called change of base. So all that means is we have 1 over. We could change this to log of b divided by log of a. So we just took one log and we split it into 2 with a division. And we can only do that with what's called a change of base law. So b becomes the top and a as the base becomes the bottom. But then we've got this algebra trick, which is kind of cool, which says you can take a fraction. If there's a fraction on the denominator, you can bring that up. Sorry, we're gonna flip this and turn it to a multiply. That's essentially what we're doing. So we have log b over log a. We're gonna flip it and turn it to a multiply. So this is originally a division question. 1 divided by, and we're gonna turn it to a multiplication. So you can bring this to the top and flip the fraction. So I've got a 1, and then I'm going to flip this and turn it to a multiply. So I'm going to put my multiply, and I'm going to flip this to log of a over log of b. Is that the same? No, it's not quite. So what have we done so far? Well, we first did a change of base. This got changed to this. And then we'll do this a lot. Whenever you have a fraction inside of a bigger fraction, that denominator, this is the denominator, it gets flipped and turned to a multiply. And so that's what I've done. Now I don't need times by 1. 1 is not necessary there, but I can do the opposite of change of base where I can put them back together. So I can turn this back to a single logarithm. Log and b is my denominator, so that becomes my base, and a is my numerator, so that stays like that. And now I believe that to be the same. Yeah, my left side equals my right side. Okay, lastly, we have this one. This is actually the most complicated. I'm going to have to go through it fairly quick here. But it's essentially the same thing. We're going to do a change of base on both of these. So I'm going to pick the more complicated side, the left side, and I'm going to do a change of base. So log of x over log of a plus 1 over log of x over log of b. And just like the last one, now I've got a fraction on the bottom. So I'm going to take this fraction and throw it up top, but flip it and turn it to a multiply. Now I'm going to be multiplying by 1, so I don't even really need that. But I'm going to flip it, so log of a over log of x plus log of b over log of x. And again, they're timesing by 1, which I don't need. And now I can put them together. They already have the same denominator, so log of a plus log b over log of x. And then we've got another log law, which says if you're adding, and the bases are the same, they both have a hidden base 10 here, but if they're adding, you can multiply. So I can put these two together by multiplying. So log of a times b over log x, which looks kind of weird, so I'm just going to write log ab over log x. Now, this is strange, because if you look at the end, we need our answer to be on the denominator. It's 1 over. So I need a 1 on top. So I'm going to do this weird thing where this is technically, I guess, all over 1. I'm going to bring this down and do the same thing, flip it. So I'm going to have this get flipped. So log x will be on top, and log ab will be on bottom. And I guess that just means we've got a 1 left up here. So that's a really weird thing where I'm taking the numerator and flipping it and bringing it down, but there is no down. I have to create the down. I have to write it over 1. So now that I have that, I can use the change of base. I can put these together with the change of base, which we've been doing a lot of. 1 over log ab and x, which I believe is what I need all the way up here. Again, this is the most complicated one. Yes, that is correct. The left side equals the right side. So you can try watching that again if you need to. It is the most challenging. Most of these other ones are done in a few steps, but this one, you can see proofs can sometimes get really complicated, and this is a good example of that.